Okay, so in this case, we've got copper sulfate, and the hydrated mass is given as 12.81 grams, and the anhydrous sample mass is given as 8.31 grams, right? And that's after effectively anhydrous. This is effectively the mass when the water has been removed. And we're asked to calculate the value of X. Okay, so how am I gonna work that out, right? How am I gonna figure out the value of X? Well, initially I do have to consider, well, what does X actually mean, right? X simply is, well, it's the value which kind of answers the question of, well, for every 1 mole of CuSO₄, how many moles of H2O are there going to be in this hydrated sample, right? Now, in order to really approach that question, what I'm going to do is I'm going to try and convert these mass values into amount of substance values, well, the relevant ones anyway, right? So in terms of the what I'm going to do first is the amount of substance of the copper sulfate, right? And the way I'm going to do that is leveraging the anhydrous mass, right? So this is effectively the mass with the without water, right? So how would I work that out? Well, I'm going to use the equation that links the moles, mass, and molar mass, right? So which is the fact that the N, the number of moles, is equal to the mass, M, divided by the molar mass, MR, okay? And in effect, in this case, that would be that the number of moles of CuSO₄, yeah, is equal to the mass M, so that's 12.81, yeah, divided by the molar mass, so that's going to be divided by, well, we're going to need to work that out. So CuSO₄, so you've got some excerpts from the periodic table here. So you've got copper here, and sulfur and oxygen, right? So copper, as you can see, 63.5, sulfur, etc., etc. So if I'm going to say, well, the MR of CuSO₄, right, so I'm going to leverage effectively relative atomic masses, right? So Cu, that's just 1, right? So 63.5. It's not times 10 multiplied by anything. It's just 1. Plus for sulfur, similarly, it's just multiplied by 1. 32.1. So, and then oxygen, that's actually multiplied by 4. So that's going to be 16 times 4, right? And so if you work that out, that's going to give you the molar mass in this case, which in this case is going to be 159.6, right? And that's going to be in grams per mole, right? Okay, so beyond that, if we look at, well, we need to add this here, so 159.6, and what's that going to give us, right? Okay, I've just realized I made a mistake here. What I've done is I've used the anhydrous mass instead of, I've used the hydrated mass instead of the anhydrous one. Yeah, well, yeah, that value should be 8.31, right? Yeah, so yeah, hopefully you didn't make the same mistake. So anyway, yeah, when you work this out, you're gonna get 0.05 2068. Okay, and that's going to be in moles, right? Okay. So we also need to work out the number of moles of the H2O, right? So how are we going to work that out? Well, you've got the hydrated mass, which is the this value here, and you've got the anhydrous mass. Because this is the mass where H2O is absent, and this is where H2O is present, the difference between these two masses is effectively the mass of the H2O. So if we really want to work out the mass of the H2O, all I need to do is do 12.81 minus 8.31, right? And that is effectively going to give you 4.5 grams, right? And therefore, if we're going to say, well, the number of moles of H2O, what's that going to be? Well, we can say the number of moles of H2O is going to be 4.5 from this divided by the molar mass of H2O, which in this case is going to be, so 1 times 2. Let me just put this here, mR of H2O plus you got to add the relative atomic mass for the oxygen, so that's going to be 16, and that's going to give you 18, right? 18 grams per mole, right? Just divided by 18, and that is going to give you 0.25, right? 0.25 moles, right? Okay, so we've got these kind of these values now for the H2O and the CuSO₄. One of the things we do need to look at as far as comparison wise is, okay, well, the number of moles of CuSO₄ compared to the number of moles of H2O, right? And what values are we gonna have? Well, what we're gonna have is 0.052068 and 0.25, right? And these are I've put CuSO₄ on the left hand side for clarity, just because as you can see above here, right, it's on the left hand side, so yeah. But anyway, yeah, so what we're trying to do here, well, we're asking the question, well, for every 1 mole of CuSO₄, how many moles of H2O? But the issue is that this is not a 1, like this is not 1 mole on the left hand side, so we want to get it to be a 1. And so it's a question of, well, how do we do that? And the way I'm going to achieve that is dividing this value by itself, right? So I divide that by 0.052068. We're going to get 1 on this side, right? Because you divide it by itself. On the other side, well, we also have to divide it by the same value, because it's a ratio. What you do on this side, you also have to do on that side, similar to what you do on either side of like an equation, right? So so I have to divide that by 0.052068 as well. Which gives you 4.8014, right? Now x is actually needs to be an integer value, right? And so this value I have here, I'm gonna round it to the nearest integer value, And so effectively what I'm going to say is that, well, 1 is in a ratio with, and what does this round to? This rounds to 5, right? So it rounds up to 5. So it's going to be 1 in a ratio of approximately 5, okay? And therefore, I'm going to say, well, x is equal to 5. And therefore, the formula, remember we've got CuSO₄ here we're dealing with, so it's going to be CuSO₄ dot 5 H2O. Alright? And so this is effectively our this is our formula in this case. And so up here where it says enter your answer in the space provided in the formula, we're going to have a 5 here, right? Okay,